Hello, sixth graders. Let me fix my thing there. All right, so I know I'm a day late for dress up day here, but because that was on Tuesday. But since I didn't have a video for you guys for Tuesday, I thought I would do it here on Wednesday for you guys. Trying to at least just kind of dress good and feel good, right? And just do something a little bit different here as we go through these weeks, and kind of the same thing happens every single day. So it just kind of, I don't know, felt kind of good to put on the shirt and tie again, since I haven't had one on for a couple of weeks. So let's go through our class notes. As you see, there are a number of subheadings that are on your document. And so like we've been doing for remote learning here, those subheadings are the titles of the slides that you need to copy down. And when we're on those slides, make sure that you copy down all the bullet points to get all the points that you would need. Pause it as needed as you go through it, so that I think it works out the best. It's the most effective if you are typing about the bullet point that I'm talking about. So don't let myself just kind of keep talking and you're a couple bullet points behind, and then you pause it at the end of the slide before I move on. I don't think that's quite as effective as when you do it like you're typing while I'm actually talking about it. All right. So let's go ahead and take a look at the slides here. All right. All right. So this is where we left off on the last document. So we have a new document here now today. Oop, I gotta click on it. Okay. So the first thing is graphing motion. And there are a couple of different ways that we can graph motion. So the graph that you see over to the left is a speed versus time graph, because if you look at the two axes, you have speed on the y-axis and time on the x-axis. So that's one type of way to graph motion. You could also do a distance versus time. So distance would be on that y-axis and time still on the x-axis. So we're going to focus here on speed versus time at graphing motion today. So when you see an upward slope, meaning that the line is on a upward trend, that means that the object is increasing speed, because obviously on the y-axis, that's where speed is going here, up on the y-axis. So that would mean, that speed is increasing. So if that's happening, you're having an increase in speed, that means that there must be an unbalanced force acting on an object, because unbalanced forces causes change in motion, like speeding up, slowing down, or changing direction. So next on this graph, you see this flat slope here. And like it says on the graph, it's a steady speed. When you have a flat line like that going across, that means that it's maintaining a constant speed. And so because it's maintaining a constant speed and there is not a change in speed or direction, it is a balanced force acting on the object. And so if you remember back to last week, that is one of the big misconceptions that people have. And it was even in the Edpuzzle video there on that last question. And I try to put like a little voice over it to correct it. But if there's balanced forces, it does not mean no motion. It means no change in motion, right? And so a steady speed would be no change in motion. Going the same direction, going the same speed, that's no change in motion. So that's a balanced force. Okay, let me move my screen here. Okay. And then the last one, downward slope. Obviously, then, if it is sloping downwards, then it would be a slowing down, or maybe even coming to a stop, which would be, again, an unbalanced force. All right, next slide. How do we describe motion? Well, motion is actually pretty difficult to describe. We just do it because we're usually using the same reference point, and that reference point would be on Earth. So let's start by saying this. Motion is relative, and it's relative to a reference point that the object is being compared to. So here's kind of a funny example that I would normally do in class. I normally would put some, like the question ball or basketball or football, up on my front table, and I would just start class by asking, is this object moving? And many people would say no. And then there's some smart people, and you're probably one of them, that would sit there and say, well, wait a minute, I guess I could say that it is moving in a certain circumstance. And you would be correct, right? That certain circumstance would be if you weren't on Earth, right? If you were at the International Space Station, or if you were on the moon, and you were able to look down on Earth, and you saw Earth spinning, well, everything on Earth then is in motion, because the Earth is spinning. And if you were somehow able to see all the way down into our classroom, onto my front table, and to see that ball, you would say, yes, that ball is in motion because it is part of the rotation of Earth. It's not in motion to us in the classroom, though, because if our reference point is being there on Earth and we're in the classroom and we're looking at the ball is not in motion according to that reference point. So who's right in that situation? Both people are right in that situation. It's not that one's right and one's wrong. It's the fact that motion is relative, meaning it's all based off of that reference point. It's comparing it to that reference point. And compared to that reference point, if it's moving or not, then you can determine if it's in motion. All right. Well, what is the definition of motion? Motion has occurred if the position or the distance of an object has changed relative to that reference point. Okay, relative to that reference point. An object's motion can be described differently depending on the reference point. And I just gave that example with the volleyball or whatever type of ball I might have put on the desk, right? If you change the reference point, then all of a sudden, the object's motion is described differently. So it's all based off of that reference point. Pause it if you haven't finished yet. I'm going to move on to the next slide. All right, so let's take a look here. Comparing motion to a reference point. All right, I think this is kind of a good way to do this. Here's my number one hint when you're trying to figure all this stuff out. If you're trying to figure all this stuff out and they're giving you different reference points, okay, be the reference point, even if that's an inanimate object, right? Like, let's go through the first one here and I'll give you an example. So a diver dives off of a high dive, Describe the diver's motion relative to the diving board. Well, that's not a living thing, right? That's an inanimate object. But if you pretended that you were the diving board and you could see, what would you see when the diver jumps off of you? Obviously, your description of the motion would be that the diver is moving away from you, right? It's moving away from you based off of that reference point. So again, put yourself at that reference point to be able to tell it out. That's what the best hint I can give. Look at the second one here. Describe the diver's motion relative to the water. Well, if it's relative to the water, put yourself as the water or in the water. Well, if you're looking up and you see this diver coming down, it's coming towards you now. So to describe that motion is that it's moving towards the water relative to the water, right? If that's the reference point. Okay, is the diver in motion compared to his or her swimsuit? Now, this is an interesting one. The swimsuit is moving at the exact same speed as the diver. And when that happens, according to that reference point, if it's moving the exact same speed, you would say, no, it's not in motion. I know this sounds weird, but pretend you're the bathing suit, right? If you're the bathing suit, it's actually moving at the same speed as the diver itself, so it doesn't appear to be in motion. Let's go back to the example with the ball that I have at the front of the desk. You're saying it's not in motion. The person on the moon saying, yes, it is on motion. Or I'm sorry, it is in motion. Why isn't it in motion for you? Well, exactly the same reason with the swimsuit. You're moving at the same speed as the ball on the desk as the earth spins. And so because of that, it doesn't appear to be in motion for you. All right? So let's go through another example here. A man on a plane gets up and walks towards the back of the plane. So give a reference point that the man is moving away from. Well, as you think about this for a second, I'll give you 1 second to think about it. What could be a reference point that the man is moving away from? All right, so maybe you thought of, well, whoever they're traveling with. So maybe they're traveling with he's traveling with his wife. So his wife's still in his seat, and he's walking to the bathroom in the back of the plane. So that would be, if his wife was the reference point, he's moving away. Give a reference point that the man is moving toward. All right, well, if he's going towards the back of the plane for the restroom, take a second, think about what would be a reference point that the man is moving toward. Okay, maybe you thought of one of the people that was sitting in one of the last rows of the plane. So all of a sudden they look up and they see the man walking towards them as he's going to the bathroom. And then here's that third one about when the person is not moving compared to. So how would you do that? Well, in a plane, it might be a little bit difficult because the aisle is so thin. But if someone got up and walked with him and was talking to him as they were walking down the aisle to go to the back of the bathroom, maybe his wife got up with him and they're walking down that center aisle. If they're walking at the same speed and they're right next to each other, technically, compared to his wife in that instance, he would not be moving. He would not be in motion. All right, so obviously there was nothing for you to copy down on this slide. These were just some examples to kind of go through to show you how you can compare motion to a reference point. So let's keep going. Balanced and unbalanced forces affect our motion. So you might notice that this is a slide that we already had last week, but I put it in this week again because I think it's super important and it's completely relevant to what we're talking about. So when we have unbalanced forces, we know that that causes a change in motion. That change in motion would be relative to whatever that reference point is. Those are the three things that we know it can do. It can either speed up, slow down, or change direction. When you add up the sum of all those forces and you figure out the net force, that net force then would be in the same direction of the motion. So if it's moving this way, that means then the net force is also moving in that direction. If the net force is in an opposite direction of the motion, then that's going to cause the object to start to slow down and possibly even get to a point where it's not in motion anymore. It's going to stop. Again, in relation to the reference point. Balanced forces then cause no change in motion, like we were talking about. No change in motion for those balanced forces. No change, right? And so go back to the graphing slide when it was that straight line, when the speed was constant, that meant there was balanced forces acting on the object. Right? And there it is. Maintains constant speed and direction. No change in motion. Remember, for balanced forces, yes, if the object's already at rest, then it stays at rest because there's no change in motion. But if it's already moving, then that means balanced forcing acting on the object would cause no change in motion. So no change in the speed or the direction of that object. So it would be moving at a constant velocity in the same exact direction. Okay, that's it for the notes for this week, guys. Like I said, if you need to go back and watch any of this, you can. Keep taking your notes. Your notes are going to be important because we're eventually going to have a test on this. Actually, I think it's going to be next week. Yeah, I think it's actually going to be Monday of next week is what I'm going to put it on the agenda for you guys to do. And it's going to be open notes. So it's important to have your notes and to pay attention to these videos so that you know which document to go back and look and which documents to have open to help you as you go through and do the notes. All right. Hope you have a good day. We'll talk to you soon.